So welcome to the videos for Shaughnessy's class. I don't have the disclaimer sheet handy, but reminder, please show up to class. This is probability and set theory, lesson 1, and so let's just get going. Set theory. Now the first thing with set theory that we had to remember is that there's definitions that we have to consider. The set, the universal set, and a Venn diagram. Okay? A set is a list of elements sharing something in common. The universal set is the biggest thing that you're considering. Like, where does this set come from? What country, what city, what classroom, what group of people, all that sort of thing. That universal set is determining that. Now, we have the universal set. We'll label it U, and you'll see that in a minute. The Venn diagram is just using the circles. Now, you've done Venn diagrams before. Okay? So if I look at this example here, within the universal set of single-digit natural numbers. Now those are the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? Not zeros, no decimals, no negatives, no anything. That's just that. Draw set P. Well, within the universal set, we've got the universal set. Okay? So we use a box usually when we're doing a Venn diagram. We label it U. And we're trying to say, okay, that is our universal set of single-digit numbers. Now from there, set P is inside there, so I'm going to draw a circle in there. And there's no worries about, the size or relative size of this. It's not a big deal. The odd numbers are going to go inside set P. So the odd numbers are 1, 3, 5, 7, and 9 in no particular order. Okay, so once you've got them, that's set P. Within the universal set, but outside of P, you've also got 2, 4, 6, and 8. Now, it doesn't matter where you go, but those are the elements that are outside of P. Now, when we continue on with this, we've got the complement of sets. The complement of sets includes the elements that fall within the universal set, but outside of this set. So, if I ask, the symbol has got this little prime symbol. Now, I'm not sure how well it shows up on the camera, but it basically is like an apostrophe, A, and there's a little tick. Now, it's not an apostrophe, it's like a little tick, it's a little slash, it's a little whatever you want to call it, primed. So in the situation above, what elements are in P primed? So what this is asking is what is the complement of P? Or more specifically, what elements are within the universal set, but not in P? In P primed, that is where we've got the elements 2, 4, 6, and 8. Okay, so you've got that. That is the complement of P. Those are the elements that are within the universal, but not in P. Now, continuing along with this, within the universal set of numbers between 0 and 20 inclusive, how many elements are in A set of multiples of 4? So you start thinking, well, you've got the numbers 0 to 20 inclusive. The multiples of 4 are 4, 8, 12, 16, and 20. Okay, so how many elements are within the multiples of 4? Well, these ones are in the multiples of 4. There's 1, 2, 3, 4, 5. There's 5 of those. So that's how many there are. Okay, in A primed, well, it's asking me what elements aren't in that set area. So from 0 to 20 inclusive, there are 21 elements. If you count them, write them out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way up to 20. There's 21 numbers there because you've got the 0. 5 of them are within A, so 16 of them are not within A. Okay? Draw a Venn diagram for this situation. Well, once again, you're going to draw your box for your universal set. Okay, you're going to label it U. That's just kind of U for universal. You've got set A somewhere in there, and I'm going to make it kind of smaller here. Set A, and set A has the multiples of 4. Now that is the 4, the 8, the 12, the 16, and the 20. So they're in set A. What numbers are not in A, but within the universal set? Well, everything 0, 1, 2, 3, 5, 6, 7. 9, 10, 11, 13, 14, 15, and then it's going to go 17, 18, 19. Okay, So there's your elements there. Now if you count them, hopefully that's 16. If it isn't, then I made a mistake earlier. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 elements in A primed. Okay? So once you've got that, you're getting used to the idea of sets. Now a couple other interesting things about sets. When we list them, we usually use these. These are called braces. They're kind of like that bracket. It's up above the enter key. It kind of looks like this. Okay, that's what we're using. I do whatever I can for those. Oops, sorry. I do whatever I can for those. As long as it kind of looks squiggly, it's a brace, I'm okay with it. But go from there. Some people have an easier time than others of making those. In fact, I couldn't make them for the first number of years of my teaching career. So you've got that. That's set, subset, that's set, universal set, and Venn diagrams. The next thing I want to talk about here is subsets. Okay? Subsets, the first set is a subset of the second if all the elements contained in the first set are also included in the second set. Basically, it's if everything that you've got is within another set, then you can say if everything is in that set, it's a subset of the other. Now how we do that, the symbol is this. It kind of looks like a sideways U. It kind of looks like a C, but it's smaller. You'll notice that when I put letters in, and I'm just going to randomly put letters, okay, it's smaller than the other letters. This is A is a subset of B. That's what this is saying. A is a subset of B. Now what that is telling me, and if I made it up, okay, so don't go thinking I'm talking about set A from before. Don't go thinking there's something specific. If A is a subset of B, then all of the numbers or all of the elements or all of the situations in A are also included in B. Now they may be the same, they may not be the same, but they're all included. Okay? So once you've got the idea of subsets and this little symbol, then you can ask yourself questions like this. You can say, is A a subset of, in this particular one, let's just look at, is A a subset of B? Okay, so is A a subset of B? And that's what I'm asking. So basically what that wants from this question here is, are all of the elements in A also in B? So we start checking. 2 is, okay, that's good. 3 is not. Set A has a 3 and it doesn't have it in B. That's all I need. Now that I see that there's at least one, no, it's not a subset, and I'm done. Okay? I continue on with this whole idea here. I can say, is C a subset of B? Okay? And so C is this smaller set here. Okay, 2 is there. 5, there's no 5. So once again, it's a no. Okay? I could ask a third question here, and hopefully this one works. Is C a subset of A? And so I can look, okay, well, C has got a 2, and A has got a 2, so that's good. C has got a 5, A has got a 5, C's got a 13, A's got a 13, C's got a 19, A's got a 19. Since all of the elements in C, okay, are also in A, yes, it's a subset. Now, it could be exactly the same size. It could be everything, but all of them are there. That's okay. That's allowed. Okay? So when I talk about these things here, then you can get into this idea. In the following 3 sets, set M is the set of multiples of 6 less than 50. Okay, the universal set is integers less than 50. So that's how far I'm going. A is all the multiples of 6 less than 50. N is the multiples of 5 less than 50. And O is the multiples of 3 less than 50. You could write this out. Okay, this is 6, 12, 18, 24, 30, 36, 42, and 48. And that's it. That's what's in M. Instead, N, you've got 5, 10, 15, 20, 25, 30, 35, 40, and 45. And in this one, you've got 3. This one's bigger. 6, 9, 12, 18, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. Okay, so this one here is big. It's got lots of things in it. So I'm just going to put little braces around each one. Okay, and I can ask you this: is A a subset of B? Now, even if I didn't, or sorry, not A is a subset of B. Is M a a subset of M? Is N a subset of M? Okay. So is N a subset of M? Basically, are all of the numbers in N also in M? Now you can look at this by looking at the list, or you can think about the mathematics. You know the multiples of 5 are 5, 10, 15, 20. Not all of those are multiples of 6, so I could answer no very quickly. Okay, I could ask, is O a subset of N? Okay, so O is this number. It's much, much bigger. O has more things in it than N. How possibly could all the things in O be in N? So no, that's not true. That's not possible. Okay. Then I could ask, is M a subset of O? Okay. Now, I think you're seeing the pattern of my examples here. But yes, 6, 6, 12, 12, 18, 18, 24, 24. Basically, it's every second one. So you've got that. The other thing, too, you can think about is the fact that if it's a subset, it has to be at least smaller than or equal to what you had before. Now, when you look at empty sets, okay, continuing on that subset. Empty set. A set that contains no elements. Things that there's no possibility, okay? So the symbol is a 0 with a slash through it, or an O with a slash through it. It's essentially an O with a big slash. Now it is a big slash. It's not theta. It's not like some of us draw O or 0. Sorry, I'm yawning today. Basically, that's how it's done. So here's an example of an empty set. From a universal set of numbers between 0 and 20, set P includes the numbers greater than 100. So the universal set is the numbers from 0 to 20. And set P is anything that's greater than 100. There is nothing greater than 100 between 0 and 20. So set P, okay, is empty. Set P is there. Whoops, set U, that's the universal set. You've got set P, which is the numbers greater than 100, and there's nothing in it. You've got all the numbers out here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and it's between 0 and 20, but I'm going to put 20 in anyway. I'm going to pretend it says inclusive. Okay, but basically everything's in there. Set P is here, and there's nothing in it. Okay, none of these numbers that are within the universal set are within set P. So P is an empty set. Okay, P is an empty set. There's nothing that satisfies it. Okay, and so with set theory, this is kind of where we go with a lot of this. Okay, also too, along with this, we get the idea of disjoint sets. Okay. Disjoint sets are two sets that share no common elements. Okay, so if there's no connection, okay, so once you've got disjoint sets, if A and B, explain why these two are disjoint. They are disjoint because there are no even numbers that are also odd. Essentially, there's nothing that's in common. There's nothing that would be in both sets. They don't count. They're exclusive. They don't touch. So you can go on and look at other sets. Disjoint is just a term. So if I give you set A, which is the set 1, 3, 5, 7, 9, and I give you set B, which is 2, 4, 6, 8, okay, are the pairs of sets below disjoint, complementary, or neither? They are both within the universal set from 0 to 9. So in this case here, from 0 to 9, okay, these don't include everything. These it's not the, it's, you can say automatically, no, they're not disjoint. I know they're not disjoint. Okay? Are they complementary? So complementary means that everything within one and everything that's not within one would be in the other. And in this case here, it almost looks like they'd be complementary, but you're still missing the zero. So this would be a no. Okay? This would be neither. Okay? When you continue down this road, I could do this one here and here. Okay, these are neither, or they're disjoint as well, I guess you could say. They don't touch. Okay, then you've got 1, 3, 5, 7, and 9 for A. And if I give you 2, 3, 5, and 7. Okay. In this case here, I'm looking, there's some overlap. They're not disjoint, so I can't say that. They're not complementary because I don't have everything that's missing from one in the other. So these are neither. Whereas I can give you ones like this, A and B. Okay, and I can give you 1, 3, 5, 7, and 9. And I can give you set B, which is 0, 2, 4, 6, or 8. And in this case here, I can look at that and say, well, they're disjoint. I know that much. Okay? Because they don't touch. Okay? But are they complementary? Which means, is everything, that's a comma, it doesn't look like it. If everything that's not in A, but within the universal set, is in the other, these are complementary sets. And that's what I've got here. Because the numbers that aren't within A are 0, 2, 4, 6, or 8. Because they're all within the universal set between 0 and 9. Okay? So that's where this comes from, and those are complementary sets. A lot of this homework and a lot of this idea was just looking at terminology. Okay? Right now we've introduced the idea of a set, which is listed in a brace. Okay? You've talked about the idea of the universal set, which is the largest group of things that you're considering. Then we've looked at disjoint sets, we've looked at empty sets, we've looked at complementary sets. So we've gone through and looked at all those things, so hopefully this makes sense. Your homework would have been on your unit outline. Okay, I think for this unit it would have been as follows. So if you look at the notes, you've got this. I don't know if this shows up very well. Okay. But for the basic homework, you've got page 14 to 18, 5, 9, 11, and 20. And as well as page 20, number 1, 2, and 3. So we've done kind of two sections of the textbook here. The mastery homework is the same as above, plus a little bit more. So take a look, go with it from there. Hopefully that makes sense. And if you have any questions, just come ask. Otherwise, have a good day.